Hi, hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. In this particular video, we are going to actually start writing the CSI plugin that we have been talking about in some of the previous videos. So in the previous videos, we have looked into what exactly is CSI specification and how does it relate to Kubernetes, or how Kubernetes can be integrated with CSI plugin using CSI specification. So if we talk about CSI plugins are actually storage provider specific. So for example, let's say there is this storage provider that wants that their volumes can be provisioned, their volumes can be used on a Kubernetes environment. In that case, they are going to write a CSI plugin for their specific storage volumes, for their specific volumes, let's say. So for example, if DigitalOcean provides storage services, in that case DigitalOcean is actually going to write the CSI plugin for Kubernetes, implementing the CSI specification or by following the rules that has been specified in the CSI specification. Similarly, for example, let's say if EBS wants to, or if AWS wants that users, Kubernetes users should be able to use EBS volumes in Kubernetes clusters. In that case, they are going to write CSI plugin for EBS, so that EBS volumes can be managed or can be used in Kubernetes cluster. Again, that plugin is going to be EBS specific, and it is going to obviously follow the rules, follow the protocol that has been specified in the CSI specification. So that is what we will be trying to achieve in this particular video, or at least we will be starting to achieve. I'm pretty sure that we will not be able to complete the entire thing in one video. That is the reason I'm saying we will be starting to achieve writing the CSI plugin, very simple, trivial CSI plugin, I would say. Obviously this is not how I have not written a CSI plugin that is running on production, so I don't have that experience. But yeah, if you know Go well, and if you go through these videos, I'm pretty sure that you would be able to write a pretty good CSI plugin. Now, if we talk about the documents, the blog posts that I have referred, so this is a pretty good blog post by Fatih. The other obvious reference is CSI specification, and I have also referenced CSI DigitalOcean, or DigitalOcean's CSI plugin source code repo. So maybe I'll link that down as well. Now, if we talk about how exactly are we going to start writing this plugin, so initially, let's say if I have to write a particular server, we know that we are going to write a gRPC server. And if we try to run this gRPC server, obviously we are going to need some details about this gRPC server. For example, let's say obviously this gRPC server is going to be a CSI plugin, so we would need name of the CSI plugin. Then we would need, for example, other things. Let's say endpoint. So where this particular gRPC server is running, and the other thing, one of the other things that we need is maybe let's say client to interact with actual storage provider. So in our case, the storage provider is going to be DigitalOcean. So here we would need storage API, let's say, to interact with storage related resources of DigitalOcean. So these are some of the fields, let's say, that we need to have for a particular server or driver. So we are going to start with creating a driver struct, and since this particular driver struct can expect some things, some fields from users, that is the reason we are going to also make it, or we are going to accept some arguments, some values as flag to this particular application. So for example, we can expect, let's say endpoint, where do we want to run this particular server. We can also expect some other details. For example, to interact with the storage provider, we would also need a token to authenticate this particular server. So we can also expect a token. So we are going to initialize this driver from another source file, let's say, and in this source file we are going to expect some arguments, some details, let's say, using command line flags. So this is how we are going to start writing this application. Now let's just go ahead and try to write this. So I'm going to create a directory called let's say the plugin that we are going to write is named block storage on scale. So I'm going to name it bsos, and let's cd into that. So I am in that directory now. I also have a Kubernetes cluster up and running, if you see here. And let's go ahead and open the text editor here. Now, like any other Go project, we are going to create main.go file, and we are going to start with main function, and let's initialize go mod here. So go mod init, and then we are going to specify the name of the module. So I'm going to name it github.com my github handle, and then project name, so bsos, and this should have created a go.mod directory here, sorry, go.mod file here. Now go mod tidy, and what we are going to do now is, in this main.go file, we are going to do the exact same thing that we talked about. So for example, we are going to expect some things as let's say command line flags to this particular application. So to do that, let's say we are going to start with at least endpoint. So this endpoint is going to be the endpoint where our gRPC server is going to run at. So flag dot string. If you do not know this flag package, this is an inbuilt package. You can read about it. We can use this package to actually accept values or command line flags to our application. So this expects the name of the flag. So I'm going to name it endpoint, and then I think it takes default value. So I'm going to call it default value, and then it also expects, I think, usage. So endpoint our gRPC server would run at. After endpoint, we are also going to expect token, because again, to interact with the storage provider, our driver eventually is going to interact with storage provider, and we would need a token using which we are going to authenticate ourselves against the storage provider. So flag.string, and this is going to be token, and default value is again going to be default value, and token of the storage provider. Now the other thing that we are going to expect is region. So it depends on your use case, but in this particular application, we would like to give, let's say, whoever is deploying this CSI plugin to specify which particular reason they want to, let's say provision volumes in. That is the reason we are going to accept reason as well. So string, and this is going to be reason, and default value is going to be, let's say, AMS3. This is Amsterdam 3, and then reason where the volumes are going to be provisioned. Now let's just go ahead and try to build this very simple application. So endpoint token, and then reason. Okay, so we see these values. Default value ms3. Okay, now what we have to do is we have to get a new driver's instance. So create a driver instance, and then we are going to call run on that driver instance, and that run is actually going to, it would start the gRPC server. So before actually creating the driver instance, let's go ahead and if you look at this particular diagram, we are going to create this driver struct, and to create that, let's create a directory called package, and then driver inside package, and let's create another source file called driver.go, and inside driver.go this is going to be in driver package, and let's create a struct called driver, and this driver is going to have some fields that we already looked into. For example, name of the driver, reason. Apart from that, endpoint obviously, and we are just going to start with these many fields, but obviously when we move forward with the videos or the video, we are going to obviously add fields here, remove fields, or improve the code. And we are obviously also going to need or going to have the server, gRPC server that we want to run, and this is going to be gRPC, not this gRPC. Let me just copy the package quickly. I have written the package name already, or I think that would be helpful. So gRPC dot server, and if I try to build the project again, and we are also going to need the storage client, using which we can actually interact with the storage service. So in our particular example, we are writing a CSI plugin that is going to dynamically provision the volumes on DigitalOcean. That is the reason we are going to have everything related to DigitalOcean. We have already set up that understanding that a CSI plugin is written for specific storage providers. So we do not actually need to have that field right now, but we would add that field when we need that. And we are also going to have a new function called new driver, and this is going to return driver instance. So return driver, and obviously if you see here, new driver is actually going to accept the things that have been passed to our application, and that is the reason we can either pass these things that we are getting from the users separately, or we can have another struct, and we can pass these values using that struct to our driver. So let's call that type input params, and this is also going to be input, and string endpoint is also going to be string token, and I think this is pretty much it. And it is going to, new driver is going to accept input params, and it is going to return a driver instance. So now let's go ahead and try to call new driver to get that instance. So driver Let's import that package github.com Vivek Singh GZITS / bsos / package and driver. So driver dot new driver, and it is going to accept input params, and then it is going to give us driver, and then we are obviously going to run method on driver that is actually going to start the server, register the implementation, etc., that we are going to look into in just a bit. So now what we have to do is we have to actually pass the things that we got from the users or from configuration, let's say. So name is going to be right now I'm actually deciding not to accept the name, so we are going to hard code the name in our source file. So const, and we are going to say default name is going to be, let's name it bsos.viveksingh.dev, and we are going to use that in our main.go file, and endpoint is going to be the endpoint that we got from the user, and then again reason is also going to be the reason that we got from the user, and token same for the token. Now that we have the driver instance, what we can do is we can go ahead and try to call run method on driver, and this run method should actually do the magic of starting the gRPC server like it's specified in the CSI specification. So again, let's note that down here. Start the gRPC server according or like it's mentioned in the CSI spec. So driver name is going to be params.name, endpoint is going to be params.endpoint, and reason same for the reason. And I think that's pretty much it. We are going to use token in just a bit, but for now let's keep this as it is. We are going to need token when we initialize the client to interact with the storage provider, but we are not going to use this right now. Now let's go ahead and try to create a method on driver, and this method is actually going to start the gRPC server, and it is going to return an error if there was an error starting the gRPC server. So I think what we can do now is we can just go ahead and try to run the server, and if there is an error starting the server, we can just log that. You can try to handle it as you want, but for now I'm just going to log this. So error %s running the driver, and it is going to be this. Now again, like I said, this is not how you are going to write a production ready CSI plugin. This is just going to give an idea of how all these components come together to dynamically provision a volume, to dynamically, let's say, interact with CSI plugin. And again, if you know Go well, you are going to figure these things out. You're going to figure better ways to do this, for example. Now let's go ahead and try to build this once again. So it says gRPC, we have to download gRPC, and if we try to build this again, we are able to build the project successfully, and it is just logging the values as of now. Now let's go ahead and try to implement the run. So if we look at the CSI specification, in the CSI specification for the protocol, if you see here for the protocol, it is clearly mentioned that only Unix domain sockets may be used as endpoints. So as of now, gRPC servers can or gRPC servers that are implementing the CSI RPCs can only run on Unix domain sockets. They cannot run on any other scheme, let's say, right? And it is clearly mentioned in the CSI specification. So what we will have to do is we have to actually parse the endpoint that has been specified to make sure that we have the correct endpoint. So let's just parse it. So url dot parse, and we are going to parse the dot endpoint, and it is going to give us url and error, and we are going to check if there was a parsing error. In that case, we are going to return fmp dot error or passing the URL or endpoint, and the error is this. Once we have this, what we are going to do is we are actually going to, so let's assume that the endpoint that we got is in this particular format. So let's say, since we are going to run it in as Unix domain socket, let's say we got the endpoint value in this particular format. So let's say slash var let's say lib CSI sockets, and let's say CSI.sock. Let's say this is how we got the endpoint value. In that case, we will have to actually figure out this particular part, and this is going to be the gRPC address, and this is where our gRPC server is going to run. So we will have to first figure out the scheme. This is the scheme. We will also have to figure out if host has been provided. In this particular case, we don't have any host, and then we are going to actually form the gRPC address where we have to run our gRPC server. So let's go ahead and try to first check if scheme is Unix or not. If url dot scheme is not equals to Unix, in that case we are going to return an error, and that error would say only supported scheme is Unix, but provided is something else, url dot scheme. Now the other thing that we would want to do is we would want to make sure that we somehow are able to figure out this address where we are going to run the gRPC server. So to do that, what we are going to do is, in this particular case, if you see, we are not specifying any host. So if url.host is empty, in that case what we are going to do is we are going to say, let's say gRPC address colon equals to path dot join, and we are going to join host. So url dot host, and then we will also have to, so here if you see, the path separator is slash. So but this does not happen in all of the operating systems. That is the reason we'll have to make sure that we are removing this slash with the path separator that is being used in that operating system. So that is the reason we are going to say file path dot from slash, and then we are going to specify url dot path. So if you look at from slash, you would be able to figure out what exactly from slash does. So if you say here returns the result of replacing each slash character in path with a separator character, and this separator character is operating system specific. That is the reason we have to basically do this to make sure we are actually correctly parsing the URL. If URL.host is not specified, is not given, which is the case in our scenario, in that case what we are going to do is we are going to just say gRPC address is going to be file path dot from slash, and we are going to specify URL dot path. So now that we have gRPC address, what we are going to do is we are going to look into a very simple example of running a gRPC server from grpc.io itself. So if you see here, this is the example that we are going to use. So we are going to specify where do we exactly want to, let's say, where do we exactly want to start the server using net.listen, and then we are going to create a server, then we are going to actually start the server. So let's go ahead and try to do this. So net.listen, and we are going to listen on the endpoint or the port details that have been specified in gRPC address. So let's try to do that. So we are going to use scheme url.scheme, and then we want to listen on gRPC address that we figured out from the endpoint that was given. Now this is going to return listener and an error. So if error is not equals to nil, in that case we are going to return fmt.error, and it is going to say dot listen failed, and the error is this. So now that we have listener, what we are going to do is, if we look at this particular example once again, we are going to create a new server. So we are going to say grpc dot new server. We are not going to specify any server option as of now, but if we require, we are going to modify this in later videos. So we are going to call it, if you see here, we have a server field in driver, so we are going to initialize that server field with this value. So d.srv equals to grpc.new server, and this returns a pointer. That is the reason this must be a pointer. So now we have a d dot. Now we have a server instance basically, and we can now run this particular server. But before that, we actually have to do a very important thing, that is registering the implementation with the server. So for example, we are going to implement the services now. So all those RPCs that are specified by the CSI specification are going to be implemented by this driver. So we have to specify that this is the server, and this is the server basically that implements all these specifications, right? And we can do that by using this function here. That is in CSI spec itself. So CSI spec lib, and then we have to go and then CSI, and in this particular go file we would have the function to actually register the implementation. So register node server, and this is what we are going to use to actually register the node implementation, controller implementation, as well as identity implementation. So let's just go ahead and try to import this first. Okay, and we are going to say CSI dot register node server, and we are going to register. So the server is, we know that the server is d.srv, and we also know this driver actually implements. We want to make sure that or this driver is eventually going to implement all those methods that are specified in CSI specification. That is the reason we are specifying D here. Now let's go ahead and try to, just to remove this error, I'm just going to print this listener. So let's go ahead and try to build this once, just to make sure that things are working as expected. So I'm going to download this module as well. And once we have downloaded it, let's build the project again. And if you see here, it again, it started complaining that this variable of type driver value in argument to register node server missing method node expand volume. Now if we go ahead and try to look into the argument node server, so node server actually must implement or should implement all these methods that are specified here. And these are the same methods, if you remember, when we were looking into CSI specification, these are the same methods that a node plugin should implement, right? And in our particular scenario, this driver that we are going to write, this driver is going to implement node plugin, RPCs related to node plugin as well as RPCs related to controller plugin. That is the reason we are going to make sure that this driver implements those RPCs. So let's go ahead and try to create another source file called node.go, and in node.go we are going to implement all those plugins. So we are going to make sure that driver actually implements RPCs related to node plugin, and we are also going to resolve these compilation issues. And we will also have to obviously import context as well as CSI. So now if you see here, the problem has been gone. If we try to look into what exactly this register node server is doing, if you see here, it actually tries to explain what we are trying to do here. So register service registers a service and its implementation to a gRPC server. So if we see here, this is the gRPC server and this is the type that implements the specification. So we are also going to similarly register identity server as well as controller server. So CSI dot register controller server and d.srv, and we are going to specify d itself. Similarly register identity server d.srv and d. Now we are going to specifying d at all the places because driver is the type that is implementing all the RPCs of node service, controller service as well as identity service. If you see here again, we are going to we are seeing the compilation issues. So let's go ahead and try to resolve this. So controller is supposed to implement all these methods. So let's go ahead and try to create another source file called controller.go, and then we are going to implement all those methods here. So all these methods must be implemented by controller plugin, CSI.go, and we will also have to just return nil as of now because of the obvious reasons. We are not actually implementing the things. We are just trying to we're just trying to make the skeleton work, and once we know that things are working, we are actually going to implement these or our respective methods, not all the methods, but obviously respective methods. If you go to driver.go again, if you see here, this error has gone, and we are still seeing problem for identity server. So let's go ahead and try to implement the methods for identity server as well, and we are going to implement this in another source file called identity.go in driver package itself. These request and response structs are from CSI package. That is the reason I'm adding CSI. I'm returning nil and nil as of now because of the reason that I mentioned. I just want to make this work, and then we can actually try to implement this. So now if we look at it, it looks like we were able to actually get a server instance. We were able to register the implementation with the server. Now all that we are left with is starting the server. So let's go ahead and try to start it. So d.serve, and we are going to specify the listener here. So this is the listener where our gRPC server is going to listen at. Now what we are going to do is, let's go ahead and try to run this once and see what happens. So it was built successfully. If we try to run it, okay, so we are not actually specifying correct value for the endpoint. So let's go ahead and try to specify a value. So let's say we are going to specify the next colon. Let's say for now I'm going to just specify, let's say, temp and CSI, and then sockets, and then CSI.sock, and let's see what happens. So it says there is no such file. Let's go ahead and for now let's just go ahead and try to create this manually. So mkdir, and we are going to create a hierarchy. That is the reason I'm specifying -p. So the directory has been created now. And if you see here, now it looks like a gRPC server is running, and it's actually blocking call. And so we are at least able to start the gRPC server now. I think we can say that now the gRPC server is up and running. But if I disconnect, if I stop that process, let's say, and start again, we would get into a problem. It would say that address is already in use. So to resolve this, what we are going to do is, we are going to make sure that when we listen on that address, before actually listening on that address, we try to delete if the directory is already available. So to do that, what we are going to do is, we are going to call os.remove, and then remove gRPC address, and error, if error is not equals to nil, and if there is an error and that error is exists. So it simply is saying that if there is an error, and that error is not saying that error is something other than directory already exists, that we see here. In that case, we should treat that as an actual error. Otherwise, we should continue. So return fmt.errorf, and we are going to say removing listen address and the error is this one. Now let's go ahead and try to build this project once again, and then we are going to run this. So if you see here, now gRPC server is running, and if I interrupt this and try to run it again, we are not getting into that problem, because before actually starting listen address, before actually trying to listen on that socket, we are removing and then we are listening on that socket. So that is the reason we are actually able to start the gRPC server now. So now I think in this particular video, I think this should be sufficient. I'm obviously going to summarize things very quickly, and we would continue discussing other things in the next video. So uh, if I try to summarize the things, we have we have now from this video started actually implementing the CSI plugin, and we have already set up the understanding that CSI plugins are storage provider specific. That is the reason in this particular, or as an example, we are going to write CSI plugin for DigitalOcean. So this CSI plugin is actually going to provision volumes on DigitalOcean dynamically. And after that is set up, we know that when we create a plugin, when we create a driver, that driver is going to have some fields. For example, name of the driver, reason, endpoint, server, and it may also have an HTTP server. If someone else is trying to health check, let's say, in that case it can also have an HTTP server. It is also obviously going to have the storage clients to interact with storage provider. And once we have decided that the driver is going to have these many fields, we should try to make sure that if it's possible, we should try to take some fields from the configuration from the users. That is the reason we are accepting some values, some fields from the users using flag inbuilt module. And we are making sure that we are listening, or this gRPC server is running on Unix domain socket, because that is exactly what has been specified in the CSI specification. And we are writing this CSI plugin. This CSI plugin would not be called CSI specification compliant if it does not adhere to the things that have been specified in the CSI specification. So yeah, in the next video we are going to actually look into how we deploy it in Kubernetes and other things. I hope you liked this video. If you have any question about it, don't hesitate to reach out to me. Thank you so much for watching. Share it with your friends, colleagues, classmates, and I'll see you in the next one. Thanks so much.